Okay. An industrial company claims, here's my claims, that the mean pH level in the water of the water in a nearby river is 6.8. Oops, does it say is 6.8? Is 6.8. Let me shrink this down. Okay. You randomly select 39 water samples and you measure the pH of each. The sample mean and the standard deviation, it's coming from the same sentence, so that's a sample standard deviation, are 6.7 and 0.35 respectively. Is there enough evidence to reject the company's claim? If you get confused where to find a claim, look at your last sentence. The company's claim. So here is my company's claim. The claim says what? The mean is 6.8. Is this the HO or the HA? HO, because it has an equal sign. What's the HA? It's not equal. What tail test do we have? Two-tail test. So again, we're going to start with the two-tail test. We're doing reject region first, and then we're going to do the p-val test with it. Reject H0. This needs to be labeled this way. And fail to reject H0. Now, we've got two parts here that we have to have a cutoff for. One is going to be a negative, one is going to be a positive. So let's see where our sample information comes from. You randomly select 39. Now notice, 39 is larger than 30. So they didn't have to tell us that we approximated a normal distribution. If my n is greater than or equal to 30, they don't tell us that. So my sample mean is 6.7, and my sample standard deviation, 0.35. My level of significance, 0.05. What's your degrees of freedom? 38. So you are going to go to your table, table 5. You're going to look up one tail or two tails? Two tails. Two tails you're going to look up. Degrees of freedom, 38. And under the two tail, 0.05. You're going to tell me, excuse me, you're going to tell me that cutoff value, that critical value. Table 5. If you like your calc and you do an inverse T, you can do it, but just don't forget two tail, divide by 2. So what did we get? Good, very good. This is my critical value, my cutoff value. When I take my test statistic, God bless you, I see where it falls. Then from there, I'll know if I reject H0 or I fail to reject. So we're going to do your T. Your sample minus your population over your sample standard deviation, that's a decimal, divided by the square root of n. N is what's in your sample size. Either use the alpha key for this, or put parentheses around your numerator, parentheses around your denominator. So find me your test statistic. Negative 0.09. You got it off your calc? Something's wrong. Negative 1.784. We'll look at your calc in 1 second. Now, this is where I want to see. Where does this fall? My zero's in the middle. This is a number line. It falls It falls slightly right here. So, my decision is fail to reject H0. That's my decision. My interpretation. Now, if I fail to reject the H0, do I agree with it? Yeah, I agree with it. Because this is my H0 happens to be my claim. So if I fail to reject it, I have to go along with the company's claim, but I have to say there is not enough evidence at a level of significance of 0.05 to reject the company's claim that the mean pH level of the water in the nearby river is 6.8. I need that whole statement. Now, in your calc, let's look at your calc. Stat, test. We're not a Z, we're a T. T is asking for a sample standard deviation. Z is asking for a population standard deviation. My mean from my statement is 6.8. My sample mean is 6.7. My standard deviation, 0.35. My N, 39. And my tail is a 2-tailed. Did you check yours?
Yeah, my standard deviation I put 6.7.
Oh, okay. Oh, okay. Calculate. There's my t-score. You can always take your t off of here, but you need this to get your p-val. So if I'm looking for my p-val is right there. The value under my curve. Put 0.824. Round it. So to test for p-val, I do not need to make this cutoff value. I just need to do this. I don't need to say reject. I need to do this. Two-tailed test. I just need to find the area. This is my negative 1.784. This is my area under that curve. It's a little different look to this. I say p-val, level of significance, 0.0824, and my level of significance, 0.05, zeros, fill it in with zeros. This is greater than, I get the same exact decision. Okay. Now p-val looks at it differently. P-val looks at the area under your curve. Z-scores look at your z-score values, your cutoff values. I like the z-scores because you can actually see it makes more sense. The p-val is still a little bit more difficult to look at because your 0.5, technically if you split it in half, is technically over here somewhere. So wait, it's over here somewhere. So, sorry, it's in here. So this guy's a little bit bigger than that, so we're failing to reject. If it's inside of it, then it's too small, then we reject H0. But this big blue is a little bigger than what your 0.05 is, and that would split to 0.025. Okay? But your calculator takes care of that. You don't have to divide anything. If you use your calculator in your table, there's nothing you have to double or divide. It's right there. Okay? You guys try it yourself 5. I'm going to have you try this, and then I'm going to give you an assignment. I want you to do it both ways. Test reject region. Let's go over this. So, David, what's my claim?
U equals 1,890.
Okay. Is this HO or HA? Good. What's my HA? Good. Haley, what tail test do I have? Two-tail test. Not equal. Remember, not equal goes out in 2 directions. So it's going to say reject H0 and reject H0. Fail to reject H0. Okay. Naya, what's my cutoff value? Yep. You didn't find it yet, okay? All right, Dave, what's my cutoff value? Good. So in your table, you're going to look at degrees of freedom 38. You're going to find 0, 1 in the 2 tails, and you're going to come down, and it's going to give you the positive 1. So it's equal on the negative 1. Okay? Now, and I noticed the end, use the word reject. Reject the company's claim. Reject means I had an HO. Do I have an HO? good way to start. So I pull out all my sample information. 39, my sample mean is 2350. My sample standard deviation, 900. My level of significance, 0.01. Okay. I do my T. My T says take the sample minus the population divided by the standard deviation divided by the square root of 39. Angelise, what'd you come out with? 3.192. Okay, thank you. 3.192. This is my test statistic. This is the T-score from my test information that I tested with my samples. So I had 39 of them. I found out their mean, their sample mean. I come over here. I say, does it fall to the left or to the right of 2.712? To the right. So what is my decision? Good. Decision is reject HO. I can't say reject my claim. I say reject HO. It's right there. But you can tell your p-value is going to be small, isn't it? It's unusual, even in a t-score, to be this far, this extreme off my curve. Now, p-value test still does the same thing. God bless you. But now, I don't have to look at the cutoff values. I'm kind of taking the 0.05 into consideration, but I can do that with my test. I still get my T, but you're going to have to do this one in your calculator to get your p-val. So Devin, what's your p-val? I know you use your calculator.
0.00.
Okay, 0.003, 0.0028. And all you have to do is test this. Okay? If the calculator takes care of the two-tail, don't multiply it by 2. The calculator did this. P-val, level of significance. 0.0028, 0.01. I fill this with 0. And this is less than or equal to this. So my decision is still reject H0. Okay? Make sense? Yes.
Can you show me how you do that in the calculator?
Yes, because you have to be able to do this in the calc to get this. So you go to statistics, stat, you go to test. This is where your confidence interval tests were. We did a z-score test, now we're doing a t-test. And you just put your information in.
Okay.
So this is from your population statement. This is your statement, 1890. This is your sample, 2350. This is your sample standard deviation, 900. Your N, 39. And this is your tail. Follow your HA. If your HA is less than, take the less than sign. If your HA is greater than, take the greater than sign. In this case, the HA is not equal. We keep the not equal sign, and you calculate. So you'll get your t-score, your test statistic, and you'll get your p-val. And again, it repeats your parts to it. Yeah.
Is there any way you can do the inverse?
You can do inverse T on this, second bears. You can do inverse T. Two tails, just remember to divide it by 2. You can still do the same thing. Degrees of freedom, 38, and it'll give it to you on here. It'll give you the price. So you can do inverse T. I like the table because you don't even have to think about dividing by 2. You do one tail, you do two tails. You don't have to think about dividing by 2. And because you can't find the p-val, you don't have to multiply anything by 2. Your calculator takes care of that. Everybody okay with this? Pretty much the same thing. We're just looking at a sample standard deviation rather than a population standard deviation. So because of that, we get a little bit more leeway in our t-score than doing that. Because we take your degrees of freedom and we subtract 1. We take your N and we subtract 1 to get your degrees of freedom. And your chart's just slightly different. Good? All right, I'm going to give you a little assignment from the book. I'll write it here. This is a 6. Sorry. That's a 6. These three are just setting up finding reject regions. There's nothing to test. Just set your curve up, find your reject parts, your critical values. Then 15, 16, 18. Okay? So you don't have too many. I want the whole 9 yards though when you do this. Plain, H-O-H-A, sketch, label. I want your decision, and I want your interpretation. There's only 2 things you can say for decision. Reject H-O, fail to reject H-O. Then use that chart to help you with your interpretation.